this assessment tells us that the cis alkyl halide shown here undergoes E2 elimination 500 times faster than the corresponding trans compound. Now, this is a video that could take a little bit of time, but I want to make sure we think about how we solve a problem like this that is a somewhat difficult problem. Well, the thing we want to do is first look at what's the same and what's different. In each case, we are using a 6-membered ring with a tert-butyl group, and we've got the chlorine. In one case, it's down. In the other case, it's up. And so could we make some conclusion about, well, up chlorines eliminate faster than down chlorines? We could, but that wouldn't make necessarily a ton of sense. One of the clues to how to solve this comes from the fact that it's a 6-membered ring. Whenever we're confronted with a 6-membered ring, we should draw the chair conformation. And so let's draw the chair conformation for both and see if that gives us any kind of insight. With this one here, we're going to put the tert-butyl group in the equatorial position. That's probably a good idea because the tert-butyl group always wants to be equatorial, really more than any other substituent. If we do that, we put the chlorine at this carbon here, going down also in the equatorial. Do the same thing for the one over here and see if that gives us any difference. When we do that, we're still going to have the up tert-butyl group in the equatorial position, as T-butyl groups want to be. But now we're going to get the chlorine in the axial position. This is where the idea will start to emerge. Remember that in E2 elimination, we have to have an anti and coplanar hydrogen, or an anti and coplanar relationship between the proton that's being removed and the good leaving group. Well, if we draw in the neighboring protons, let's do it from the front carbon, we notice that when the chlorine is axial, this proton and the chlorine are anti and coplanar. If we draw in those same two protons in the top molecule where the chlorine is in the equatorial position, we notice that the chlorine is anti and coplanar to neither of these protons. In fact, this chlorine is anti and coplanar to this CH2. As a result, in this conformation, elimination by the E2 mechanism cannot occur. Does that mean this molecule can't undergo elimination at all? It, in fact, can, but it has to chair flip, it has to do the ring flip to the other one where the chlorine is now axial. If that chlorine is axial, then that tert-butyl group will also be axial, and we know that's not favorable. So this one ends up undergoing elimination 500 times faster because it's already in the conformation. In fact, it's kind of locked by that bulky tert-butyl group. It's locked into the conformation that gives us the anti and coplanar arrangement. Whereas this one is locked into the conformation that does not give the anti and coplanar. This one eliminates much more slowly, this one much faster. Did you like that video? Was that a good solution? Did that help? My son tells me we don't have enough subscribers yet. So hit subscribe. No, wait, let me say it the way he wants. Smash the like button, subscribe to the channel. Is that how I'm supposed to say it? Do that for any of the videos, like all the videos, and subscribe. Not for me, but for him. He's actually not over there. See you next time.